Hi, so today in this video I'm going to be covering chapter 8.1, problems 43, 45, and 69. Now looking at 43, the instructions of this problem are saying find the first four partial sums and the nth partial sum of the sequence a sub n. Now to help us, it will be useful for us if we find the terms first. So a sub 1, a sub 2, a sub 3, a sub 4. A sub 1 will be 2 over 3 to the first power, which is this 3. A sub 2 will be 2 over 3 to the second power, which will be 9. A sub 3 will be 2 over 3 to the third power, which is 27, and 2 over 81. Now we want to find the first four partial sums and the nth partial sum of the sequence. So for the first four, sum 1 will just be 2/3, and that's easy peasy because it is... it's just like one term, you aren't actually adding anything. The sum sub 2 will be 2/3 plus 2/9. To be able to add these together, we need common denominators. So I'm going to multiply this by 9 over 9, which will give me 6 over 3 plus 2 over 9. This will give me 8 over 9. I'm going to write it like this, actually. And then the sum of the first three terms will be 2/3 plus 2/9 plus 2 over 27. We all want the common denominator of 27, so I'm going to times this by 3 over 3 and this by 9 over 9. So I will get 18 over 27 plus 6 over 27 plus 2 over 27. Which will give me 18 plus 6 is 24, plus 2 is 26. So I'll get 26 over 27. And then I'm just going to add one more to this with the 2 over 81 for the last one. We want this to have 81 as a denominator, so I'm going to times this by 3, which will give me... something over 81, 2 over 81. My mental math is not working today. 60, 52. Okay, 78. Adding these together will give me 80 over 81, which will give me 80 over 81 for this. Now, this is our first part of the answer. But now we need to find a general thing, a sum of like S sub n. And to do so, it's going to be very useful to start to notice a pattern. For one, I see this is 3, 9, 27, 81. That's going to be 3 to the power of n. And n is the number in the sequence. This is the first number in the sequence, the second number in the sequence, the third number in the sequence, and the fourth number in the sequence. If you did at 3 to the nth power, you would get 3 to the first power, which is just 3, so that checks out right here. And then, let me move this to the side really quick. Then we need to continue to notice some patterns. This is useful so far. 2/3, all of these have in common that they're one less than their full thing, right? So if we do one less than their, full thing, and their full thing would be like 81 over 81 or like 27 over 27. To do one less than that would just be to do 1 over 3 to the nth power, because then you would get 1 minus like 1 over 27 or 1 minus blah, 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 blah. And that will always get you 1 like this. So our general term will be the 1 minus 1 over 3 to the nth power. Now, I knew the answer for that because I've done this problem before. Sometimes the answer is not very obvious, and it takes some thinking, but it's not going to be too hard with enough practice. So the next problem would be 45, which says a sub n is equal to the square root of n minus n, the square root of n plus 1. It's got the same instructions to find the first four partial sums and the nth partial sum of the sequence a sub n. To find the first four, I'm just going to quickly do that on my calculator. We'll just be plugging in those numbers. Give me just a moment. All right, here are my 4 terms. To be able to find the sum, I'm just going to add them together. We know that the sum of the first one will just be the 1 minus the square root of 2. The sum of the first 2 terms will be all of these added together. And when we're adding these together, it'll be 1 minus the square root of 2 plus the square root of 2 minus the square root of 3. These two here, we have a minus and a plus, so these can cross out. So we have 1 minus the square root of 3. The sum of the first 3 combined will be that one, the 1 minus the square root of 3, and then plus our third term, which is the square root of 3 minus 2. These will cross out again, which will give me 1 minus 2. 1 minus 2, which will be sorry, negative 1. And then for our last sum, we'll do negative 1, and then it will be plus 2 minus the square root of 5, which will turn into 1 minus the square root of 5. To find a general term, here, hold on, we need to look for a pattern. So it looks like in every example we have a 1 minus the square root of n plus 1, it looks like. Because like this is n plus 1, this is n plus 1. The n plus 1 here would be 4. 1 minus 2, which would give you negative 1. 1 minus 2 would give you negative 1. And then, this would be n plus 1 as well. So it looks like our general term will be 1 minus n plus 1. Last problem that I was asked to cover is 69, which, hold on, is being covered by 45, says, let me go down to the instructions again really quick. It says, write the sum using sigma notation. So to be able to do this, hold on. Sigma notation is when we use this weird like sigma, it looks like a little backwards E, and I'm never good at drawing them. I've always tried, but I'm not very good at them. And we have the number that we're trying to go to. In this case, it looks like 10. We have the 1, 2, 3, 4. We don't have 4, but it doesn't look like it's skipping any numbers. So it goes up to 10 in our spot. And then it looks like all of them are squared no matter what. And then we use k instead of n for these, so k equals 1. And then we'll have, it looks like k is our starting, k is basically a, it's our starting point, or our ending point, like whatever point we're in, whatever, what's the term? Like slot. I don't think that's a term. But it's, and then all of these are squared. So this would be our sum in sigma notation. Sigma notation looks really freaky and like intimidating, but it's actually not too bad if you know the rules. It's basically saying this is where we stop, this is where we start, and this is the equation that we use it with. And k is typically like what is seen being used. But yeah, if you have any other questions, please let me know and I'll answer as soon as possible.